Video will be about the multiple choice question that are solved and that are from chapter solid. Amorphous solid do not have sharp melting point, characteristic geometric shape, regularity of the structure, all of these. There is another question about the crystalline solid that has definite geometrical shape, flat faces, sharp edges, all of these. So there are some characteristics given for the crystalline and amorphous solids. These all properties that are given in question 1, these are the properties of crystalline solids. So amorphous solid will not have these all properties. While the crystalline solid have definite geometrical shape, have sharp edges, flat faces, these all are and that are given in the question 1, these all belong to the crystalline solids. So the amorphous solid do not have, they will not have all these properties, and crystalline solid has all these properties that are given in question 2. Element of symmetry are plane of symmetry, axis of symmetry, center of symmetry, all of these. So the element of symmetry in a crystal are plane of symmetry, axis of symmetry, and center of symmetry. What is mean by plane of symmetry? It is that imaginary plane which passes through the center of the crystal and divides it into two equal portions, just like mirror image of each other. So it is the plane that will divide the crystal into two equal half. Axis of symmetry is that imaginary straight line on which the rotation of a crystal gives similarly appearance more than one time. It is two-fold, three-fold, four-fold, and six-fold type respectively. So axis of symmetry is the line, that the imaginary line, a rotation about which gives the similar appearance more than once. That is two-fold, three-fold, and etc. Center of symmetry, it is the imaginary point which divides the surface of the crystal at equal distance in both the direction by drawing any line through it. A crystal can only have only one center of symmetry, so it is that point at which all the atoms that are present at the surface are at equal distance from that center, that is known as center of symmetry. So the element of symmetry include all of these. For tetragonal crystal system, which one of the following is true? There are four options given that will have edges. A is equal to B, B is not equal to C, and they both three are equal, they three are not equal. So for that we will use the crystal system that is known as 7 crystal system, that will include simple cubic, tetragonal, orthorhombic, rhombohedral, monoclinic, triclinic, and hexagonal. So the question is about tetragonal crystal system. So we will look at the tetragonal system in which A is equal to B and B is not equal to C. So among these options, A is the correct answer. The similar information can be used for finding the angle between the edges, angle between the faces. So orthorhombic crystal system, which is correct? So there alpha, beta, gamma, three angles are given, whether they are equal, whether they are not equal to each other. So all these options, among all these options, which one is the correct? So we will look at the orthorhombic crystal system that is given at third point, at which the alpha is equal to beta, beta is equal to gamma, and that is equal to 90. So among these options, B is the correct answer. The total number of atoms in a body center cubic unit cell is 1, 2, 3, and 4. So if we look at the body center cube, in which the cube has 8 corners and each atom is located at these 8 corners, and body center cube in which one atom is present in the center of the cube. If we look at these structures, these 8 corners are shared by further 8 corners, which mean that there is a portion that is 1/8 of these corners, and here is the full atom that is present in the center, while these atoms, these all 8 atoms will be divided by 8. So we will solve it. A body center unit cell contain the equivalent of the 2 atoms, 8 corners at 1 by 8 each, that will have 1 atom. I have told you already that these have a ratio of 1 by 8. So 1 by 8 multiplied by 8, it will produce 1 atom. Center that is unshared, that is present in center, that is not shared by any other unit cell, so it will have 1 atom. So the equivalent atoms are 2 atoms that are given over there. We can also obtain this data from the table. The body center cube, 8 multiplied by 1 by 8, it will produce 1 atom. There is no atom present at the faces, but there is 1 atom in the center. So adding these 1 plus 1 will produce 2. So the answer is 2. The shape of the crystal in which it usually grows is known as size, capacity, habit, property. So the crystal habit is the characteristic external shape of the individual crystal or aggregates of crystal. So answer is habit of crystal. The coordination number of a body center lattice cube is 2, 4, 6 and 8. So the coordination number can be defined as the number of neighboring atom or ion that closely surround the central atom or ion of a complex or crystal. The unit cell of a body center cube. So here the body center cube that is given over there, it will have 1 atom in the center that is surrounded by 8 other atoms at the corner. So the atom that are surrounded the central atom, that is the coordination number. So here the body center cube has the coordination number 8. If there are 4 atoms in the unit cell of a cubic system, it is the example of simple cubic unit cell, body center cubic unit cell, face center cubic unit cell, none of these. So first we will know about the face center cubic system, in which each atom is present at each faces. So if we look at the structure, the red atoms that are present at each faces, and the blue atoms or the gray atoms are present at the corners. So these faces are shared by 2 unit cell. So it is divided by 2. Each face will be divided by 2, and the corner atom are shared by 8 unit cell. So it is divided by 8 is divided by 1 by 8. Or we can say that in case of face center cube, that has 1 by 8 multiplied by 8, it will produce 1, and each face is shared by 2 atoms. So 6 faces are present, so it is divided by 2, it will produce 3. So 3 plus 1, it will give you 4. So the 4 atom unit cell system is known as face center cubic unit cell. For an ionic crystal of formula AX, the radius ratio lies between 0.732 and 0.414. Its coordination number is 4, 6, 8 and 12. So this table will give the information about the coordination number, radius ratio and the structure that is obtained from that coordination number. So the radius ratio lies between 0.732 and 0.44. So it will have 6 coordination number that is given in the table. Similarly, this table can be used for finding the structure of the crystal lattice. Or we can say that the coordination number or the radius ratio will be given, and we will find the structure. So that question is related to the set information. The permitted coordination number in an ionic crystal is 6. So here the coordination number is given. The arrangement of the anion around the cation will be plane, triangular, tetrahedral, octahedral, body center, cubic. So if we look at these structures, so these coordination number values, 6 is for octahedral. So octahedral is correct answer. Carbon dioxide is an example of ionic solid, metallic solid, molecular solid, covalent solid. So dry crystal lattice or for dry carbon dioxide, frozen and dry ice, that is the carbon dioxide, it is the best example of molecular solid. The van der Waals forces, the weak van der Waals forces are present in these solid that hold the carbon dioxide molecule together. So it will boil, or we can say that it will be converted from solid to gaseous state at minus 78 degrees C. So it is the example of molecular solid. Crystal structure of diamond is trigonal, tetrahedral, cubic, none of these. So we know that in diamond each carbon is covalently bonded to 4 other carbon atom in a tetrahedron or tetrahedral structure. The carbon atom are arranged in a face center cubic crystal lattice. So we know that the carbon has cubic unit cell and it has cubic structure. So the answer is cubic. The nature of binding forces in the ionic crystal is magnetic, repulsive, electrostatic and weak. So these are ionic crystal, which mean ions are present, so there will be electrostatic forces of attraction.